We're going to look at the combined gas law. So this chapter has a lot of math in it, but most of it is just filling in the equations in the right way with the right units. So keep that in mind. That's kind of a chemistry theme. If you take more chemistry in the future, you are going to have to deal with unit situations. Again, like before, I like to make a little note. This needs to be in Kelvin. This needs to be in Kelvin. These two just need to be the same unit. They could both be milliliters, they could both be liters, whatever they are, they got to be the same. And then the same goes for these ones also. They need to be the same units. It's not quite as picky as the PV equals nRT equation. This is huge though. Gotta get the Kelvin in there. And we're going to use the idea of making a little list on the side with the information we know. We need to read the problem kind of carefully. All of these have a lot more information than the PV equals nRT equations. So you know to use the combined gas law right here. You know to use it when something's changing. It's for things that are changing. Maybe they changed the container. Maybe they changed the temperature. Somehow they changed the pressure, or, there's reasons that things might change. The ideal gas law, which is a different equation, that one's just looking at a container. Nothing's changing about it. It's just looking, and they're double checking the pressure or the volume or the whatever. So because it's changing, you're going to have like a from situation and the to situation. See, from, to, again, increases from, to, and then was. So you just need to make sure you pair up the information well. So I'm going to put all of the froms together first. And then I'm going to put the twos together. So I'm seeing pressure, but again, remember, I'm just looking for my units. I'm reading this as blah, 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 blah. Oh, there's a number with a unit. Number with a unit from. So that unit, that ATM, that's a pressure unit. That's my from, my 1.00 ATM. The 2 is my other pressure unit. That's my 5.00 ATM. That's what it's going to become. Temperature increases from, so that's my first temperature. Notice that it is the correct unit. A lot of times I put temperature as the bottom as a special cue to myself that I almost always have to make sure that temperature is correct. Second temperature is 350.15 Kelvin. You probably want a little neater than that. And then the last initial volume. So it doesn't say from, but it does say initial. So that would be like at the, on the beginning end of something. So that's 12.0 milliliters. So we basically have all of these, and we don't know this one. That's the one I'm looking for. So we're going to get this by itself. And the way we get it by itself is we basically are dividing out or multiplying out. You may even like the idea of cross multiplying. Some people really like thinking of it like that, where this comes up here and this goes down there, but we're trying to get that V2 by itself. So that's one way to think about it, is cross multiplying. Or you can say, all right, I need to multiply both sides by T2 to get rid of the T2. Now I got the T2 over. And then to get rid of P2, I need to divide both sides by P2. And that would get rid of that one. So two ways of thinking of it, but you've got to get the correct variable by itself. And then just make sure the other easy thing to mess up is that you fill in the things in the wrong way. Let's make sure we've got it filled in well. That's our P1 ATMs. So right here's my ATM. It kind of should have probably matched perfectly. That's where it is in the equation. And then we've got our V1. Then we have our T1. Sorry, look where T1 is. It's down here. And then we have our 5 ATMs. That's our P2. And then we have our 350.15 for T2 down up there. By the way, this one's unit wasn't brought with it. It is a Kelvin. It's over here. Now let's make sure that all of our units cancel. Notice we have a Kelvin canceling with a Kelvin and an ATM canceling with our ATM. So this is telling us what our volume unit is going to turn out